The next one is lateral condensation. In this, a single cone. So first the master cone is mainly selected according to the size that is prepared apically. This is one of the most commonly taught and practiced filling technique worldwide. So the basic is the canal preparation, the spreader selection, accessory cone selection, master cone selection, and the sealer selection. So first, the master cone is basically selected according to the apical size, and a tuck back is checked for the apical for the apical check. Then the accessory cones are placed, so basically a spreader is first used to create space for the accessory cones. The accessory cones must occupy the space left by the spreader. Otherwise, an air or sealer filled space will result, which will not be very acceptable. So after the master cone is selected, till the spreader goes, uh, the accessory cones are continuously fitted in the canal, and condensation and addition of gutta percha cone continues until the spreader will no longer reach more than 2 to 3 mm into the canal from the orifice. Forces generated by vertical loading of the spreader are vertical and lateral. So then after that, heat serves at the gutta percha points and allows consolidation deep into the canal. So basically, after the lateral condensation is done, heat is basically used to shear off all the gutta percha points at one time, and then a spreader, a plugger is used to condense the gutta percha. So variance in cold lateral condensation is a number of measures have been reported to enhance the gutta percha adaptation and density in lateral condensation. So the first would be warming the spreaders before use in hot bead sterilizer, softening of the gutta percha with heat before insertion of the cold spreader, mechanical activation of finger spreaders in endodontic reciprocating handpiece, application of an ultrasonically energized spreader, and lateral condensation is regarded as safe and cost effective and user friendly. The major disadvantage of cold lateral condensation is very time consuming, difficult in fine and curved canals, because the spreader is not very flexible, and it's difficult for the spreader to reach till the point. The next is warm vertical condensation. It's the most widely practiced technique in today's times. So basically, the instruments that are required are touch and heat or a system B. The touch and heat unit is used with a Schilder's technique. That is, the touch and heat is an electronic device basically which is developed for warm vertical compaction of the gutta percha. So in this, the master cone is placed, which is a single master cone, and then heat is applied to sear off the GP, and a plugger is used. So the touch and heat basically has a tip which heats which heats up, and then the gutta percha point is seared off at the desirable level. So first at the orifice, and then there is vertical compression which is done with pluggers, and then you take the touch and heat again, and you keep doing it until there is only 3 to 4 mm of gutta percha remaining at the apical end. So you keep heating it and removing a part of gutta percha, and then using the pluggers to condense it again. So this creates a very a hydraulic pressure at the apex, because of which the sealer is spread in all the canals, even the lateral canals. So in case there is presence of any lateral canals, they are filled very well in this technique. So the procedure would be the softened warm gutta percha can be readily compacted apically into the irregularities of the root canal system. So first the pluggers are selected and pre-fitted, that is the coronal end, the middle, and the apical 1/3. So this is the touch and heat system. Can you see the probe which is heated, and because of which the gutta percha is seared off at the point where it's required. So down packing, the selected master cone is of a non-standard gutta percha point with the apical tip cut off, and is fitted to achieve apical tuck back at about 1 mm from the working length. The gutta percha protruding from the canal orifice is removed with a hot instrument, that is the touch and heat. The The widest plugger is now used to compact the gutta percha. That is the one that is used at the orifice, is used for vertical compaction. The heat transfer instrument is then heated again and again plunged into the mass of gutta percha to a more deeper area, as the middle third. And then again another condenser is used, a plugger is used again to compact the gutta percha to the middle third. And then the heat transfer is done again until and only 3 to 4 of gutta percha is remaining in the apical end. So the advantage is that it fills the accessory canals very well with a homogeneous filling material. Disadvantage is that voids could be created if there is inadequate control of the depth or insertion of the filler. A small plugger is ineffective, and plugger binding apically may split the root. If too much force is applied using a very thin plugger, which is a very strong metal, it could also create root fractures. So it has to be used very gently and with a lot of precision. So after the apical end is compacted, a single wave technique is used. That is, the system B heat source is used, and with the help of that, the remaining area is filled. That is, the obtura system that is available, it fills the remaining of the root canal with gutta percha that is heated, and then it is compacted again. Single wave down pack technique. These are the condensers which are used for the vertical compaction of the gutta percha points. You can see it has got a tip which is flat. So this has three sizes: the one for the coronal end, one for the middle end, and one for the apical end. So the one which is used for the coronal end is the thickest. This is a slightly thinner one for the middle third, and thinnest one for the apical third. After downpacking, obtura 2 is used for backfill of the rest of the canal. So this is the obtura 2 system, which has got a gun. So basically, the gutta percha pellet is loaded in the gun, and then it is given heat, because of which it becomes a very viscous fluid, and then which is backfilled in the remaining canal.